Okay guys, we're going to go ahead and do 9.3. Here's the warm-up, so go ahead and put me on pause and try this on your own. 15q to the third minus 18q squared minus 10q plus 12. They want me to, I believe, there's no directions, I'm going to assume they want me to factor this. This is a polynomial with 4 terms, and there is a no GCF. I was thinking 3, but 3 does not go into 10 evenly, and 2 will not go into 15. So therefore, we're going to group it. Take the GCF out of each group. In the first group, the largest number you can take out is a 3 and 2 q's. 3q squared times 5q minus 3q squared times 6 would give me the first group. I want this to be a minus. I'm noticing this is a plus, so I better take out a negative. That will turn this guy into a positive. The largest number I can take out of those is a 2. Negative 2 times 5q would give me negative 10q, and negative q times a negative 6, negative times a negative will get me my positive. 2 times 6 is 12. Notice how that your binomials right here are the same. That's the indicator that you're doing this correctly. Rewrite that one time, 5q minus 6, and then put your GCFs, group those together as the second binomial, as 3q squared minus 2. Neither one of these binomials can be factored again, so therefore that is your answer. And don't forget, you can always check your answer by using FOIL. Alright, this is 9.3, which is solving quadratic equations. Solving a quadratic equation by graphing. You guys have been taught how to solve a quadratic equation by factoring it. We're going to look at the graphing side of it. You're going to graph and you're going to find where or where not the parabola crosses the x-axis. Where it crosses the x-axis is called the roots. And roots is a fancier way of saying the answers. So really, we want to figure out where does it cross the x-axis. If you look at the first example here, this first picture, x squared minus 1, we can always, instead of writing equals 0, we can let it be a y. So y is equal to x squared minus 1. If you were to graph this, which we could use a table, axis of symmetry formula, the vertex, and if you were to graph this, then you would notice that this particular equation crosses the x-axis at -2, or excuse me, -1 and +1. So therefore this one has 2 roots, 2 answers, which are -1 and +1. Those would be the answers. If you look at the second diagram, this equation, after you graph it, you'll notice that it crosses at 0. It only hits the x-axis at one point, so there is only one root, and that root, or answer, is 0. In the third diagram, you will notice that this parabola actually never crosses the x-axis. Because it doesn't cross the x-axis, I'm going to write it up here, that means that there are actually no real roots. In other words, your roots are not real numbers. Okay, the book doesn't talk about this, but when this happens, there's actually an answer, but they're called imaginary numbers. And you really don't get into the imaginary numbers until you get into Algebra 2, which is a couple years away. So the book just says there's no real roots, but don't think that that doesn't mean there aren't any answers. There are answers. They're just not real number answers. They're imaginary number answers. Okay? All right, if the quadratic equation is missing the b term in the ax squared plus bx plus c, whether you set it equal to 0 or you set it equal to y, either case, depending on whether we're graphing, which would be the setting equal to y. If you set it equal to 0, that means that we're actually going to do it algebraically by factoring. But this is a standard quadratic equation. If it's missing the bx term, then it's an incomplete quadratic, and we can actually figure this answer out another way besides graphing. We can actually use square roots. So watch how they do this. This is actually another technique that you're going to be taught and expected to do on a test or a quiz. X squared minus 25 is equal to 0 is an incomplete quadratic. It's got the ax squared term, it's got the c term, it's missing the bx term. So therefore, one way to deal with this, anytime it's missing the bx term, you could actually just solve for the x. So add 25 to both sides. That's going to give me x squared is equal to positive 25. The inverse of squaring would be to square root. If you do it to one term, you do it to all the terms. That will cancel. Now this is where some kids are going to mess up, because when I say, what's the square root of 25? 90% of my kids are going to say 5. Well, that's true. However, 5 times 5 is 25, and let's not forget that a negative times a negative is also a positive 25. So there's two answers. It's 5 and negative 5. You will see math people will typically write it as plus and minus 5. So those are my roots. If they ask me to do a sketch graph of this, not like the ones you guys have been doing, just a very brief diagram of what this would look like, without going through all the details, you would know that since 5 and negative 5 are the roots, that means that the parabola is going to cross at 5 and negative 5. That would be here and here. Now where it crosses, where's the vertex? I do know A is equal to 1, so I know the parabola is going to open up. But where the vertex is, where it changes direction down here, I have no idea without actually figuring that out with my axis of symmetry or building a table. So I'm not going to label my y-axes on purpose because I'm literally doing a sketch graph. I'm not sure where it actually takes its turn. But I do know that this would be a fairly good approximation of what that graph would look like, because the roots are negative 5 and positive 5, and I know that it opens up because the leading coefficient is a positive. Alright, let's look at this example. This is an incomplete quadratic again. It's got the ax squared term, it's got the c term, it's missing the bx term. Anytime we do that, we have an incomplete missing the bx specifically, we can go ahead and solve and try to find the roots algebraically. That will give me 2x squared is equal to 8. Solving for my x, divide by 2. We get x squared is equal to 4. The inverse of squaring would be to square root. That will cancel that. And the square root of 4 is not just a 2, it's also a negative 2. So if I was to draw a quick diagram of what that would look like on a graph, it would look something like this. We know it's going to cross at negative 2 and positive 2 on the x-axis. And we also know that since our leading coefficient is positive, it's going to open up. Again, I'm not going to label my y-axis on purpose because I don't know exactly where my vertex is. So this is finding the roots, what we've been doing the last couple of problems of a quadratic equation without actually graphing it or factoring it. It's by actually solving for the square roots.